I'm Dan, Variable Gardens. We do permaculture design. You'll see an example of what that means later on. And a big part of what that means is building healthy soil. And we're going to go through kind of the different aspects of that we've figured out over the last 2 years or so. So if you're going to grow veggies, it's really important to basically get rid of this one way or another. We're going to talk about the good ways of doing that. Otherwise, you're going to...
Nice on pub.
What's that? Yes.
5.
Yeah.
Too low.
Like we saw outside, it might be soft now, but in summer, if we test again, it might be too compacted. Not only can plants not grow, water has trouble getting into the soil, and when it does get into the soil, so on a compacted soil, the rain hits the ground and tends to just run off the top. It's not soft and absorbent. If water does get into the soil, so if we get really good rain, or if that soil is in a depression or something like that, the water has trouble getting out of the soil because it's so compacted. So you can end up with waterlogging, and that's where there's water sitting in the soil. And the number will range from about 4 to 11, and then you compare that to the number you want, which is always going to be about 6.5. And if the numbers are different, if the numbers are the same, do nothing. It means your soil acidity is about right. If they're different, do something. And the thing you do, so you want about 6.5. This is your scale, maybe going from 11 to say 4 in terms of what you're actually going to find. If you're here, thumbs up. If you're here, you're alkaline and you need to add sulfur, which is just a yellow powder. It's not a dangerous chemical. It's fine, yeah, it's not a synthetic chemical. It's basically just a mineral. It does shock the roots and soil a bit, so ideally you do this before you plant things. But if you've got a really high pH, 8 or 9, it's just worth doing it anyway. Your plants are going to thank you in the long run.
And do you buy it as sulfur, or is it some other one?
Yeah, it's called sulfur. It's just a yellow granular powder like yellow sand. And if you add 100 grams of sulfur per square metre, you'll bring the pH down 1 point. So if your pH is 8, 100 grams per square metre, over about 3 months, will bring that down to 7, and so on.
So it takes 3 months.
It takes time for it to get incorporated and have its effect. If your soil is acid, and as a rule of thumb, these heavy basalt clays are going to be a bit acid. We did one pH test out there, and the opposite was true. It was a bit alkaline due to various factors. But if it's acid, you've got to add lime. You can probably follow the same sort of rule of thumb, about 100 grams per square metre to lift the pH by 1 point.
Can I just ask, because I was reading about this, because mine are up.
In drainage, which we've talked about, those are all going to affect how healthy your soil is, and we don't have time to go into those. But just keep in mind, it's not just the pH and how many worms, and it's not about what's in this little garden area. It's also about the context. Is it shaded all day? If it's shaded all day, it's not going to dry out as fast. It's more likely to go anaerobic and so on.
And as a rule of thumb, if you've got worms in the soil, is it healthy?
Yeah, worms are always a good sign.
Yeah.
And one of the reasons is, actually we'll talk about worms shortly when we talk about soil life. But first, soil chemistry. A large part of which is pH, which we've covered, so we're doing well. I'm going to show you a sample of what comes back if you send your soil off to a chemistry lab. And then we're going to talk about a few other things. One thing that happens, we just talked about pH. So as it ranges from 4.5 to 8 through 6.5, which is optimal, different minerals that are required. So this is, don't really have to worry about all the names, but they've got names like nitrates, potassium, phosphorus, sulfur, molybdenum, copper, a whole bunch of different stuff that healthy soil needs. But you can see as you move from low pH to high pH, each one has a different pattern. So magnesium is less available, becomes more available, and becomes less available. Molybdenum is very unavailable, but it becomes more available as you get more alkaline. And one thing that means is if you have a really healthy, diverse soil, it's actually not going to be a uniform pH. Some bits are going to be a bit alkaline, some bits a bit acid, some neutral, and that's a good thing because the roots of the plant will go and find the areas they need to access the minerals they need. So we're always looking for diversity in pH as well as anything else. On average, it should be neutral. All right. This is what comes back if you send a little bag like this off to a soil lab. There's a few around. And basically just tells you out of all the most important minerals, how much of each of them is there. Are they low, are they acceptable, are they high? So here we've got, hard to read. They also tell you the pH, in this case it's 6.5, perfect. They tell you how much organic matter you've got, worth taking this away. But the ratio of calcium should be about 5 to 1. 5 parts calcium to 1 part magnesium. And all these soil testing labs know this, and they'll always give you a percentage. So it says the calcium magnesium ratio is 1.92. And really it needs to be about 5 to 1. So here we need to add some calcium to bring that balance right. And just to explain the reasoning behind it a little bit, it's like glue in the soil, it sticks everything together. But if there's too much, it sticks. So even though the minerals are in your soil, all the other ones, potassium, boron, molybdenum, whatever, you've basically got lime, which is almost totally calcium, dolomite, which is calcium and magnesium. But if you add dolomite, because you want to add calcium, this is a very common mistake that's made. Dolomite usually has more magnesium relative to calcium than you want, so it might be, say, 3 parts calcium to 1 part magnesium. If your calcium magnesium ratio is like this, you need more calcium. If you add dolomite trying to fix the problem, you're making it worse. You're going backwards. You're sticking your soil together more, making it more solid, more compacted.
Can you test those levels yourself, or do you have to send it off to the lab?
Yeah, it's one thing you can't test at home. But we're trying to get representative feels for what the rules of thumb are. We've done that in the eastern suburbs, but not so much in the west. Actually, they pump down into the roots. So only 20% stays up there. They're pumping it down, and of that 80%, 50% of that, so 40% of all the energy they work hard to capture, just gets pumped out of their roots into the soil. What's going on? Why would they do that?
Feeding microbes.
Feeding microbes. And cut straight to the chase. And this is pretty interesting. And this is literally what happens. So let's say this is a piece of boron, a molecule of boron, which is a trace element. Trees don't need a lot of it, or veggies, but they need a little bit. And let's say that's over there, and I'm a broccoli, or let's say I'm an apple tree. Now my roots, they can only extend maybe 10 metres from the tree. That's as far as I can reach, and I can mine the soil for minerals and nutrients. But I know there's more out there, and I want it. One thing I can do, I can't get over there. Trees can't walk over there. You know, they were stuffed before they figured out that there was. We need a volunteer here. Would you mind? Thank you. Fungi. So you're a fungus in the soil, and the way it works is I say, look, I'm the apple tree. You're the fungus. Now I can do something you can't. That's use photosynthesis to generate cakes and cookies, which you want. That's what fungi eat. Protein, carbohydrates and sugars. I'm going to give you some of those in return for that boron. Would you mind? Thank you. So the fungi is basically it's a mining mechanism. They've got these hyphae, these pipes. Thank you, and here's your cakes and cookies. So there's these complex exchanges happening in the soil. Trillions of times a day, you know, there's these amazing things going on, and it's very symbiotic, and the microbes are going and harnessing nutrients that the trees and the veggies can't reach. And they're actually extending the area of soil by a factor of 10. So if the fruit tree can reach 10 metres, with the help of the fungi and bacteria, it can reach 100 metres. And under forests, they find these ridiculous webs of these kinds of bacteria. Mushrooms glow in the dark. This is a picture of a complex web of fungal hyphae. That, as we said, can reach further than plant roots, they can grow faster than plants, and they can literally eat rocks. They can exude enzymes that can break down rocks and access the minerals in the rocks and take them away. One way or another, you start with bare rock. And the first bugs to come along and start building soil are bacteria that make the way for lichens and mosses, and then slowly annual weeds and then perennial weeds and grasses and shrubs, and then you end up with trees. And as that's happening, as you're moving through from bare rock to, say, a forest, you're moving from a bacterially dominated to a fungally dominated soil. And any kind of plant you want to grow, say it's a fruit tree or a vegetable or a herb, they'll have a preference for how much bacteria is in the soil relative to fungi. Trees like more fungi. That's why we put wood mulch on the surface, because that breeds up more fungi. Veggies like it a bit more bacterial. So just like the calcium magnesium thing, that's another thing that certain plants prefer more than others. You don't really have to worry about it, because if you do everything else right, the plants themselves will feed the bugs they want. They'll make a symbiotic transaction with the ones they're after. But that's all going on in the soil as well. And one thing it's a mistake to do is to think, I want to get rid of the weeds, so I'll pull them up and take them away, put them in my green waste bin. With the exception of cockatoo and couch grass, those weeds are full of nutrients that your soil needs. So pull them up, turn them upside down, and let them decompose where they stand.
You always wonder, is that just going to make them
Yes.
spread and get worse?
I'll just show you. I'll show you an example of a weed-free garden we made.